Hello everyone, and welcome back to the Fluctus Channel. A failed landing on an aircraft carrier can turn a routine recovery into a fight for survival in seconds. On land, a pilot may have thousands of feet of runway, emergency vehicles nearby, and space to slow the aircraft after touchdown. At sea, the runway is a moving steel deck surrounded by open water. The aircraft must arrive at the correct angle, catch an arresting wire with its tail hook, and stop before the landing area disappears beneath its nose. If that system fails, there is almost no time for discussion. Training, instinct, power, and crew coordination must take over immediately. Arrested landings are the heart of carrier aviation. Heavy cables stretch across the angled flight deck, connected below to machinery designed to absorb massive landing energy. When an aircraft lands, its tailhook drags across the deck and catches one of the wires. The cable pays out through arresting engines beneath the deck, slowing the aircraft in a controlled but violent stop. A landing that looks normal from outside still sends powerful forces through the hook, cable, airframe, and pilot. The carrier may be steaming into the wind. The deck may be rising and falling, and other aircraft may be waiting overhead for their turn to recover. The E-2C Hawkeye shows why this system is so important. Hawkeye is not a fighter. It is a carrier-based airborne early warning aircraft with a large radar dome mounted above the fuselage. Its crew watches the battle space, tracks aircraft, supports command and control, and extends the carrier strike group's awareness far beyond the horizon. Because of that mission, the E-2C must launch and recover from the carrier like the fighters it supports. Even though it is larger, slower, and shaped very differently from a jet built for combat maneuvering. A Hawkeye launch begins with the aircraft positioned on the catapult. Wings spread, engines turning, and crew strapped inside. Flight deck sailors check the launch bar, hold back fitting, control surfaces, and surrounding area. The catapult fires, the aircraft accelerates hard, and the Hawkeye climbs away to begin its surveillance mission. Recovery reverses the danger. The pilot lowers landing gear and tailhook, lines up with the angled deck, holds power steady, and commits to the landing. The hook catches. The wire stretches, and the aircraft should stop before the end of the landing area. The screw tops incident showed how fragile that moment can be. On March 18, 2016, pilots from VAW 123 aboard USS Dwight D. Eisenhower landed an E-2C Hawkeye when the arresting cable snapped after touchdown. Instead of stopping, the aircraft continued toward the end of the deck, forcing the crew into an immediate survival response. Navy reports later noted that the pilots maintained control and received the Armed Forces Air Medal for valor. The incident became a powerful reminder that carrier pilots are trained to keep adding power after touchdown, because a missed wire or failed cable can still demand flight. At that moment, the aircraft was no longer simply landing. It was balancing between recovery and disaster, while the ocean waited ahead. The safety system behind these recoveries requires constant work. During cable installation, crews handle heavy components, route cable systems, align hardware, and inspect the machinery that will absorb landing energy. Advanced arresting gear testing pushes the system before pilots rely on it. Test teams check cable behavior, load response, reset timing, controls, and safety limits. Every recovery system must be ready for repeated impacts from aircraft weighing tens of thousands of pounds. Even with careful maintenance, carriers train for the worst. Flight deck crash and salvage teams practice responding to damaged aircraft, fuel fires, blocked landing areas, and injured personnel.
Fire, fire, fire! Let's go, let's go, let's go! 314 and 83, let's go, let's go!
They move hoses, rescue tools, firefighting gear, tow equipment, and medical support into position. When a landing fails, seconds decide whether the deck remains chaotic or becomes controlled again. The pilot may be fighting to keep the aircraft airborne, but the ship is already entering survival mode with him. That is why every safe recovery is treated as proof of preparation, not luck, because the sea gives no runway beyond the carrier's edge. During the most dangerous final seconds, the carrier landing story becomes even more extreme when the aircraft was never designed for a carrier at all. The U-2 Dragon Lady was built for high-altitude reconnaissance, not shipboard recovery. Its long, glider-like wings, bicycle landing gear, light structure, and extreme altitude performance made it one of the strangest aircraft ever tested at sea. In the 1960s, under Project Whaletail, the United States explored whether U-2 aircraft could operate from carriers, giving strategic reconnaissance missions a way to launch from the ocean instead of depending only on fixed land bases. The idea was bold because the U-2 is difficult to land even on a normal runway. It produces lift easily, floats at low speed, and rests on a narrow centerline landing gear arrangement. On land, chase cars often follow the aircraft, with another pilot calling height over the radio as the Dragon Lady settles. On a carrier, the challenge became far more dangerous. The deck was short, the ship was moving, and the aircraft had to stop before floating past the landing area. Carrier testing required modifications, including an arresting hook and structural reinforcement. A U-2 carrier approach demanded extreme patience. The pilot lined up with the ship, reduced speed, kept the long wings level, and tried to place the aircraft onto a deck far smaller than any normal runway. The Dragon Lady did not want to land hard like a carrier fighter. It wanted to keep flying. The pilot had to manage power, sink rate, and alignment with delicate control. Then let the hook catch the wire before the aircraft drifted away or ran out of space. The first successful U-2 carrier landing came in March 1964, proving that the unusual concept could work under controlled conditions. The launch process also revealed the aircraft's special nature. On land, crews prepare a U-2 by fitting temporary wing support wheels called pogos. These hold the long wings level during taxi and the early takeoff roll. As the aircraft accelerates, the wings begin producing lift, the pogos drop away, and the Dragon Lady climbs toward the edge of the atmosphere. At altitude, the pilot manages sensors, fuel, oxygen, navigation, and aircraft handling for hours. The mission may be quiet, but the workload remains intense because the U-2 flies near the limits of its performance. Returning to Earth is another test. The aircraft descends carefully, aligns with the runway, and balances on its bicycle gear before the wings finally settle. Compared with the E-2C cable failure, the U-2 story shows a different kind of survival mode. One aircraft fights to keep flying after a failed stop. The other is so efficient that landing itself becomes the fight. Both demand calm hands, exact timing, and complete trust in training when the margin for error almost disappears again. Arrested landings are not only a carrier problem. On land, military airfields need systems that can stop aircraft during emergencies. A fighter may return with brake failure, hydraulic problems, damaged landing gear, battle damage, or too little runway remaining. In those moments, the pilot lowers the tailhook and aims for a cable stretched across the runway. Instead of rolling off the pavement, the aircraft catches the cable and is slowed by arresting gear on the ground. The BAC-12 is one of the best-known land-based aircraft arresting systems. It works as an emergency braking system for tailhook-equipped aircraft, using a cable and energy absorbers to slow the jet. Certification begins with inspection. Airfield and power production teams check the cable, anchors, tape, barriers, arresting engines, runway markings, hydraulic systems, and control points. They make sure the cable sits at the right height for an aircraft hook and that the system can pay out smoothly under load. A certification engagement confirms the equipment is stable and ready for real emergencies. The test process is controlled but serious. An aircraft approaches the runway at planned speed, lowers its hook, and catches the cable. As the aircraft rolls forward, the arresting system absorbs the energy and brings it to a stop. Afterward, crews inspect the cable path, reset the system, record measurements, and look for damage. The goal is to prove the equipment before a pilot needs it during a real failure. Mobile aircraft arresting systems take the concept into temporary or expeditionary operations. At air bases such as Kunsan, crews can deploy portable arresting equipment to support fighters when fixed infrastructure is not enough. The system must be placed accurately, because a misaligned cable can miss the hook or create unsafe forces during engagement. The M31 arresting gear follows the same survival logic. When Marines conduct mock emergency arresting exercises, crews install and test the gear before the aircraft arrives. They check spacing, cable condition, anchor points, response procedures, and communication between the runway team and pilot. The aircraft then practices an emergency engagement, proving that the ground system and cockpit crew can work together under pressure. These land systems connect directly to the carrier deck. Whether an E-2C is saved after a cable failure, a U-2 is tested on a carrier, or a fighter catches a BAC 12 on a runway, the principle is the same. Aircraft carry enormous energy, and crews must control that energy before it becomes a disaster. Survival mode begins long before the emergency. It is built into training, cable testing, inspections, crash drills, and pilots who keep flying when the first landing plan fails. That is why arrested recovery remains one of aviation's most dramatic safety systems. It turns danger into a second chance for the pilot, the aircraft, and everyone waiting at the end of the runway or deck. Every stop is bought through preparation daily. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.